Okay, so uh, so in this section, in regards to complex numbers, they want us to write each expression in standard form, a plus bi. So um, if you think about this, it's very similar in how we solve regular or simplify regular equations or expressions. So for example, if I had 4 say 4 plus 5x plus say negative 8 plus 2x, okay? All right, what would you do here? You would combine the numbers, right? And then combine the ones that have variables in them, right? So you would combine the 4 and the negative 8, and then you would combine the 5x and the 2x, correct? So you would get 4 plus negative 8, and then plus 5x plus 2x, right? And then you'll get 4 plus negative 8 is negative 4, and then 5x plus 2x is going to give us 7x, okay? And then that would be our answer there. It would be negative 4 plus 7x. Well, simplifying it in rational expressions, I'm sorry, in complex numbers is going to be the same thing or similar. All right. So let's say that we rewrote this as 4 plus 5i, okay, plus negative 8 plus 2i. Okay. So again, I want to combine the ones that are just regular numbers and then combine the ones that have i's. All right. So again, the 4 and the negative 8 I combine, and the 5i and the 2i I combine. So again, we get 4 plus negative 8 plus 5i plus 2i. Okay. And so our result would be negative 4 plus 7i. And then that will be our answer there. Okay. So they want us to write an expression. So remember, there's a difference between an expression and an equation. So an expression, these are expressions. We're not solving for a particular variable. We're just simplifying. So expression means to simplify. Okay. All right. If it was an equation, right? It said solve this equation, then you would have, if it was an equation, then it would have been like 4 plus 5i plus negative 8i plus 2i equals, say, 7. All right. So the equation, there's an equal sign there. That's the difference. Okay. So when we're just doing an expression, you just simplify it, right? We're not solving for a particular variable. Also, I just want to make a note. It says in standard form. So right here, it says standard form. So standard form, okay? Standard form A plus BI, okay? So it can be like in this case, negative 4 plus 7i. It can be negative 4 minus 7i, right? It doesn't have to be necessarily a positive A and a positive B. Okay, so don't get that confused. It's just saying it should be in this form. You have the A in the front and the B in the back. Okay, that's all that's saying. All right. So this is writing an expression in standard form in regards to um, complex numbers. Okay, so again, the goal here is we want to simplify this, all right, in standard form. All right, so the first thing when I look at this problem, right, we have parentheses, and of course the parentheses are going to that's the first thing you want to do is attack the parentheses. And particularly here we have a negative in the middle, so there's a -1 there. All right, so that means we're going to distribute that to each term. Okay, so then this becomes -8 plus 4i minus 2 plus 2i. Okay, so again, that's what I would do first is make sure you distribute that negative. Then we're going to combine like terms. So again, I'm going to combine the ones with no number, I mean with no variables, and then combine the ones with variables. So we have -8 minus 2, and then plus 4i plus 2i. So that gives us -10 plus 6i. That's our answer there. So again, just make sure that you distribute that negative to both terms. So that's a pretty common mistake that students make when trying to simplify this in standard form. All right, so again, we're talking about parentheses here, so that means we need to distribute, right? So we're going to multiply 3i to each of these terms. So, okay, so 3i times -3, and then 3i times 4i. So let's write that down here. So we have 3i multiplied by 3 plus 3i times that by 4i. So 3 times 3 is going to give us 9i, right? The 3i times 3 is going to give us 9i. Then here we have the 3 times 3, which is 12. And then I times I, which is going to give us I square. Okay? Now remember, I square is the same thing as saying -1. Okay? So in this case, then we'll have 9i plus 12 times -1. So that would be 9i minus 12. Okay? Or, oh, one thing, again, we have a negative here. So let me go back here. We have 3i times -3, so that should have gave us I should wrote down 3i times -3. That's a negative 9i, a negative 9i, and negative 9i. Okay. So again, we want it in this form, a plus bi. So we're going to put the -12 in the front and then the I in the back. So that's going to be minus 9i. Right? And then that will be our answer there. All right, so we want to multiply these two complex factors here. And I'm actually going to show you two ways to do this, okay? So the first way is what a lot of people are familiar with, which is using the FOIL method, right? So I'll write method 1 and the FOIL method. So first, outer, inner, last. Okay, so so in this case, our first numbers are going to be the 5 times 2. The outer numbers are going to be the 5 times -i. The inner numbers are going to be 3i and 2. And then the last numbers are going to be, or the last terms are going to be 3i and -i. Okay, so we're going to get 10 -5i, 6i, and -3i squared. All right, so when we combine this, well, these two, right, -5i plus 6i, that's going to give us just I. And then this one here is, well, we have I squared. So that's going to be -3 times -1, which produces a +3. Okay, so when we combine this, we're going to get 10 plus I plus 3, or in this case, it would be 13 plus I. Okay. All right, so I know a lot of you are familiar with method one, so keep doing that. The other way I want to present this, in which is basically the same thing as the FOIL method, um, is just basically distributing the terms. So I break it down to two parts. I have the 5 times 2 minus I plus 3 times 3I times 2 minus I. I like this better because now I know what I'm distributing. But again, if you like method one, that's fine. Okay, so I'm going to distribute the 5 here and then the 3I on both terms. So we'll have 10 minus 5I plus 6I minus 3I squared. All right, so again, we combine those together, giving us just I. So 10 plus I. And then again, the I square here is going to give us a -1. So -3 times -1 is going to be a +3. Then we combine these numbers here, well, that which gives us 13 plus I. Okay, so two different ways of doing it, same result. Okay, so when we solve these types of problems, remember um, back in, say, maybe intermediate algebra, we learn how to rationalize an expression. So, for example, if we have 2 over radical 5, okay, if we want to get rid of the radical 5, we would multiply top and bottom by radical 5. So that gives us 2 radical 5 on top. And the bottom there, well, they're the same radical. So that means I can just put the numbers inside that radical. And that will give me radical 25, which is basically just 5. Okay, so we have an expression here of 2 radical 5. We want to get rid of or eliminate the radical and denominator, so we multiply top and bottom by the same radical, and that's how we would eliminate the radical and denominator. Well, we'll do this very similar to this problem here, but instead of rationalizing the denominator, what we're going to do is we're going to multiply by the conjugate. Okay, so multiply by the conjugate. Okay, and what that means is it deals with the difference of squares. Difference of squares. Okay, so remember the difference of squares is a squared minus b squared, and then that could be factored down to a minus b and a plus b. All right, so when it says multiply by the conjugate, that means if I have a minus b, the conjugate would be a plus b, and vice versa. If I had a plus b, the conjugate would be a minus b. So for example, if I had x squared minus 9, right? This will be factored into x minus 3 and x plus 3. So if I had x minus 3, the conjugate would be x plus 3. And vice versa, if I had x plus 3, the conjugate would be x minus 3. So again, the goal here is to eliminate the I in the denominator or get rid of I in the denominator. So in order to do that, we need to multiply this by the conjugate. Okay, and these types of problems a lot of students miss because they don't multiply by the conjugate, or they multiply by the same factor. So, which you don't want to do. So I'm going to multiply this by the conjugate. So in this case, that would be 5 plus 12i over 5 plus 12i. Okay? So, and we haven't changed the expression at all because 5 plus 12i divided by 5 plus 12i is like saying 1. Literally, it's 1. When you divide those two, you get 1. So 13 over 5 minus 12i times 1 is the same thing. Okay? All right. So another thing I like to do in regards to these problems is I leave the top alone. I don't do anything to it unless it's going to help me simplify the problem. Okay? So I just kind of leave it in factored form on the top. 13 times 5 plus 12i. Okay? So I just leave it alone for now. If it's going to help me, great, then I continue on with it. Okay? And in the bottom here, again, notice that the 5 minus 12i and the 5 plus 12i, those are just the difference of squares, right? This is the a minus b, and then you have the a plus b, okay? So I just like using the difference of squares. It's so much easier than using the FOIL method, trying to multiply all this out. You're more than welcome to do that. If that's easy for you to do, please continue to do that. But again, I have this formula. I have the a squared minus b squared. So I'm just going to use that. I'm just going to use that formula and plug it in. So a in this case is going to be my 5. So that's going to be 5 squared. And then my b in this case is going to be the 12i. And notice that in the middle is always a minus. It's always a minus in the middle. So this would be my 12i. Okay, so now we get 25 minus and then 12i squared. That's going to give us 144 I squared, right? 12 squared is 144, and then we have I squared. Remember, I squared is the same thing as -1. So that's going to give us 144 times -1. All right, so that's going to give us 25 plus 144. So 25 plus 144. So that gives us 169 on the bottom. Okay. So everything here is still the same. Okay. All right. So we want to write this in this form. So that means then I will need to distribute this. Okay. But before we do that, what do we notice about 13? And 169.
169 is divisible by 13.
Exactly, right? So again, I can distribute this if I want to, but again, I noticed that 13 and 169, right? We can they're divisible. So I'm going to, so let me just write this out here. Okay, so I'm going to simplify this by 13 goes in 13 one time, and 13 goes to 169 13 times. Okay, so I'm going to write my answer down here. Right, so in this case, we're going to have 5 plus 12i over 13. Now, you can write your answer this way. This is acceptable. Or if you want to break this down further, you are more than welcome to, as 5 over 13 plus 12i over 13. Or you can also write it in this way, 5 over 13 plus 12 over 13i. Either one. All of these here are acceptable. Okay, so again, the first thing you want to do is you want to multiply by the conjugate because you want to get rid of the I in the denominator. So we're going to multiply the top by 1 plus I and then the bottom by 1 plus I. Again, we're not changing the expression because it's like multiplying by 1. Okay, and then I'm going to do my scratch work on the bottom here. So SW stands for scratch work. So I have 2 plus 3I times 1 plus I, and then I have 1 minus I times 1 plus I. Okay, so I'm going to multiply this out. So I have 2 times 1 plus I plus 3I times 1 plus I. Again, if you don't like doing it that way, you can use the FOIL method. You'll get the same answer. Okay, so we have 2 plus 2I plus 3I plus 3I square. Right, so I'm just distributing the 2 here, distributing the 3I there. So that's going to give me I get combine these together. So it gives me 2 plus 5I. And again, I square is -1. All right, so that's 3 times -1 will give us a -3. Okay, so then that gives us a -1 plus 5I. All right, so that's what we get for the top. Now here for the bottom, we have 1 minus I times 1 plus I. Again, I can use the FOIL method or this method I just used, or again, this is the same thing as the difference of squares, right? So A minus B, A plus B, and we can use the formula A squared minus B squared. So 1 is my A, and then I is my B. Okay, and then again, there's always a negative in that in the middle there. So that gives me 1 minus I square, which is going to give me another -1. All right, so that's going to give us 1 and 2 negatives will give us a positive. So 1 plus 1 will give us 2. Okay, so let's write this out. So the top there, we got -1 plus 5I, and the bottom there, we got 2. Again, you can leave your answer in this format, or if you want to break it down further, you can leave it as -1/2 plus 5 over 2I. Or you can have that I on the top with the 5. Okay, and so this is our answer here, or this one. We're going to continue on our theme here. So our goal is to eliminate I in the denominator. So that means we need to multiply by the conjugate. So we're going to multiply this by, since we have -2I, the conjugate would be just 2I. So positive 2I. So the top and bottom. Okay. All right. And then I'm going to do my scratch work here on the bottom. So I have 2 minus I times that by 2I. And then I have -2I times that by 2I. So I'm going to distribute that 2I to each term. So when we do that, we get 4I minus 2I squared. So again, remember I squared is just -1. So this is 4I minus 2 times -1. So that would be 4I. Two negatives will give us a positive, or -2 times -1 is a positive 2. Okay, so we get 4I plus 2. Here, when we multiply this, we're going to get -2 times 2, which is a -4, and then I times I, which gives us an I square. Okay, so I square again is -1. So 4 times -1, sorry, -4 times -1 is going to give us a positive 4. Okay, so let's write this out here. So the top we get 4i plus 2, and the bottom we get 4. So we want to simplify this. So notice on the top there, we have a factor of 2, or I have a common factor of 2. So we can take out a 2, leaving us with 2i plus 1, and then the denominator is 4. So we need to do that in order to simplify this rational expression, okay? All right, so 2 goes into 2 one time, and then 2 goes into 4 two times. So we get 2i plus I, sorry, 2i plus 1 over 2, and then we can break that down to 2i over 2 plus 1 over 2. And then we keep simplifying this, so the 2's here are going to cancel, leaving us with I in the first term, and then we have plus 1/2. Again, they want us to have it in a plus bi form, so let's go ahead and rearrange that. So that gives us 1/2 plus I, and that would be our answer there. Yeah. So we know I square, is equal to -1, right? So if we rewrite this, okay, if we rewrite this as I square raised to the 7th power. So remember, a power to a power, you multiply. So 2 times 7 will give us 14. Or you can write out I square 7 times, okay? So, but we know I square is -1, right? So if we just raise that to the 7th power, that's like saying -1 times -1, again, 7 times. Or since this is an odd, then our answer will just be a -1. Okay. For this one, right, same thing. Again, if we don't remember the pattern, that's okay. We can break this down as I squared times I, and I squared is equal to -1 times I. So that's going to give us a -I, and then we just bring down the 4. So that gives us 4 minus I. And then that will be our answer for the second one. Okay. On there. Okay, so notice on the previous problem, I had I squared raised to the 7th power, right? So I know that I squared is -1. So if I divide 178 divided by 2, I'm going to get 89, right? So 89 times 2 is 178. So if I rewrite this as I square raised to the 89th power, okay? So, because 2 times 89 is 178. And then I know that I square is what? It's -1. So -1 raised to the 89th power. Well, again, you can multiply -1 89 times if you like, but that's going to take some time. Or we know this is an odd number. 89 is an odd number. So that means our output, our answer is going to be a negative, right? If it was even, then it would become a positive. Since it's odd, it's going to be a negative. So -1 raised to the 89th power is just -1. So that's our answer for that one. Okay. Um, for the second one, I do this something very similar, but in this case, we have an odd power. So we're going to break this down into two parts. We have I to the 164 times I to the first power. Okay, because again, if you have the same base, you can just add the powers. 164 plus 1 is 165. Well, again, as I did on the previous one, if I did do 164 divided by 2, all right, that's going to give me 82. So I can rewrite this as I square raised to the 82, right? Because 2 times 82 is going to give me 164, and I still have that I lingering on the right side. Okay, I squared is a -1. Raise that to the 82nd power times I. Again, we have an even number here now, So that means that negative is going to be positive. So that's going to be a positive 1 times I, which gives us just I. Okay, so we have 4i cubed minus 2i squared plus 1. Again, I'm going to be using the fact that we are given that I square is equal to negative 1. So let me write that down here. So again, I square is equal to negative 1. Well, I cube, again, if you don't remember the pattern, that's okay. We can just break that down to I squared times I. And I square is negative 1 times I. So that gives us a negative I. Then we just bring down that 4, which gives us 4 times negative I, which is a negative 4i. This one here, again, I square is negative 1, so we'll have 2 times negative 1, which gives us a negative, I'm sorry, a negative 2. Bring down that negative 2. Negative 2 times negative 1, which gives us a positive 2. So let me erase that here. So that's a positive 2, and then bring down that 1 there. So we got negative 4i plus 2 plus 1. So that gives me negative 4i plus 3. And they want it in standard form, so we're just going to switch these. So that gives us 3 minus 4i. Okay. All right, so we have a negative in the exponent, so we cannot solve it this or simplify it this way. We have to have the power to be positive. So there's a rule, if we have x to the negative 1, we can rewrite this as 1 over x. So we're going to apply that same rule here. So this is going to be 1 over I to the 23rd. Okay. Now, once we have it to this part, so let's simplify I to the 23rd. And we've done several of those. So I to the 23rd. So this is going to be my scratch work. So I to the 23rd, I can break that down to I 22nd times I to the 1st, right? So I to the 22nd, I can break that down to I square raised to the 11th power, and I still have that I to the 1st. So I square is negative 1. Raise that to the 11th power times I. Well, this is an odd power, so that means my output is still going to be a negative 1 times that by I, which gives us a negative I. Okay, so in this case, we have 1 over negative I in the denominator. Okay, so once we get here, it means we need to continue on, right? Because we can't have an I in the denominator. So that means then we need to get rid of the I or eliminate the I in the denominator. So in order to do that, we need to multiply by the conjugate. So we have negative I, so the conjugate would be just I. So I over I. Okay. So that gives us I times, we have a negative 1 times that by I times I will give us I square. Okay. So we have negative I and negative 1 times by, oops, I got too many negatives here. Rewrite that over. So we got the I on the top, negative 1 times that by I squared is negative 1. So negative 1 times negative 1 is a positive 1. So I divided by 1 will just give us I. And that's our answer here. All right, so based on this definition, so it says if n is a positive real number, we define the principal square root of negative n, denoted by square root of negative n as the square root of negative n equals the square root of negative ni. What does that mean? So let's say we have the square root of negative 9. Okay. If we follow this format, okay, what is our n going to be? Yeah, so if we have square root of negative I and we follow this format right here, okay, our n is going to be is 9. So this will be square root of 9 times I, and the square root of 9 is just 3. So this will be 3i as our answer. Okay. Let's try another one. So let's say we have square root of negative 64. So following this format, our n in this case is going to be 64. So we have the square root of 64 times I, and we know the square root of 64 is 8i. Okay. So let's try another one. So square root of negative 8. Okay, so if we follow the format here, this is going to be the square root of 8i. And we can break down that 8. And remember, that can be broken down to 2 times 4. And so the square root of 2 is square root of 4. So square root of 4 is just 2. So we get square root of 2 times 2, or 2 square root of 2. So this is going to be 2 square root of 2i. And that will be our answer there. So again, we want to determine whether this statement is true or false. Are these equal, yes or no? So if we look on the left side here, we have negative 25 times negative 4. So if we multiply those together, we're going to get 100, right? Negative times a negative is a positive. 25 times 4 is 100. So we have square root of 100 here. And the square root of 100 is going to give us 10. So the left side, we get 10. On the right side, we just learned that this here, based off the definition, this is going to be the square root of negative 25 is going to be 5i. And the square root of negative 4 is going to be 2i. So if we multiply the ones 5 times 2, that's going to give us 10. And then we multiply the i's, that's going to give us I squared. Well, I squared is equal to negative 1. So, and then we bring this 10 down. So 10 times negative 1 is going to give us a negative 10. So 10 on the left side we get 10, on the right side we get negative 10. So these are not equal. So this statement is false. Okay, so the first thing you want to do is you want to label your A, B, and C. So there's a 1 here, right? So this will be our A, this is our B, and then that's our C. And then we just plug in our information. So we have negative 4 plus or minus the square root of 4 squared minus 4 times A, which is 1 times C, which is 8, divided by 2 times 1. So normally what I like to do is I look inside the radical and see if I get a solution. So we get 4 squared, which is 16, and then 4 times 1 times 8 is 32. Well, that's going to give us a negative 16. So in the real world, right, we can't take the square root of a negative number, but until we would stop and we would say we would have no solutions. However, we're dealing with complex numbers. So in this case, what we just learned, the square root of negative 16, that's just going to give us 4i, right? So again, in the real world, we would say no solution. But again, in the complex or imaginary world, we do have an answer here, which is 4i. So in this case, we're going to have negative 4 plus minus 4i divided by 2. Now, I noticed that each of the right terms has a factor of 2. So that means on the top part, so again, I can only do this if each of my terms has a factor of 2. If this was, say, a 5, I couldn't do it. Any odd number, I couldn't have done it. I can't say, oh, this is going to give me 1 and that's 2. That's false. I can't do that. Okay? So each term has to have a even, in this case, a factor of 2. So I can take out a 2, and that gives me negative 2 plus or minus 2i divided by 2. Okay, so now I can eliminate that 2, and then our answer here is going to be negative 2 plus or minus 2i. All right, so a radical, all right, so let's dive into this term here, radical, which is basically the square root, okay? So if I have y is equal to the square root of x, what does this graph look like? Well, you can always use an XY table and plot those, and it will give you an idea what the graph looks like. Or if you remember by memory, y equals square root of x, that's just, it looks like a uh, football being kicked into a field goal or a ball being thrown up in the air. All right, so something like this. Okay, so this is y is equal to square root of x. So this is a radical graph or the square root graph. Okay. Now, here's my question, right? So here's 0, all right? What number, are there any numbers here that will not work for the square root of x? Again, we're back into the real world. We're back into the real world. Are there any numbers here? Or are any numbers, are all the numbers going to work?
X couldn't be a negative number.
It couldn't be a negative number, right? So if we type in, square root of -4 in the calculator, it's going to give us an error. Okay? So again, we're back in the real world. It's going to give us an error. All right? Why is that? So why is that? So if we look at the graph, why would it give us an error?
Because then you'd be taking the square root of a negative number.
Look at the graph. Look at the graph. Why would it give us an error if we typed in square root
The,
of -4?
the graph only shows positive values.
It only shows positive values, right? We got 0, 1 to infinity, right? It's only positive values here, right? Including 0. So if I were to go to the negative direction, right? So -4 or -8 or whatever, it cannot compute it because there's nothing there. There's nothing to compute. The graph doesn't exist there. Graph doesn't exist. So the calculator is saying, I don't know what you're talking about. There's nothing here that I can't do anything. Okay, so again, pictorially, graphically, this is what's happening. That's why we're getting an error. Okay, now let's say we have um, the square root of x equals 3. What's happening here? How many equations do you see?
One,
Oh,
Is it two?
2. What are they? What are the two equations?
Y equals square root of X equals
Uh-huh. Exactly. So y1 is equal to square root of x, and the other one is going to be y2 is equal to 3. Okay? So we just established that y equals to square root of x, looks something like this, right? So what does y2 equals 3? What does that look like?
The start of the graph would be up instead of at 0.
Okay, true. So where would be at up? What number?
3.
3, right? So, and what kind of graph is that? It would be what?
It'd also be a radical graph.
No. Anybody
would it be
remember?
linear?
Say again.
Would it be linear?
It's a linear, right? So it's going to be a straight line, right? It's a straight line. So y equals 3 is just a straight line, a horizontal line. And again, over here, this is a y is equal to square root of x. Again, we need to understand the graphs. If we don't understand the graphs, then the equations is just a bunch of gibberish. It doesn't make any sense. So what if I had, say, x is equal to 2? What kind of graph would that look like?
That would also be linear.
It'll be linear. Which way is it going to go?
Would be vertical going up from x. X
Perfect.
equals 2.
Exactly. So we have marked down 2 here, and then we'll have a vertical line here. Okay? So that's why math can be complicated because it has multiple representations. So x equals 2 can be a point, but it can be a vertical line, such as y equals 3. Y equals 3 can be a point on the graph, but it could also represent a horizontal line. Okay? So in this case, when we're solving these radical equations, just like how we did for solving just linear equations, where we were trying to see, do they intersect? Are they parallel? Or are they the same line, right? Because we have one solution, zero solution, and infinite amount of solutions, infinitely many solutions when we're solving linear equations. In regards to radical equations, we're trying to do something similar is do they cross? You know, when we solve this, at what point do they cross? Okay? Or do they cross at all? Okay? So that's what we're doing. So when we're solving these radical equations, what's the behind the scenes? And it's important to understand the behind the scenes so that when we have an answer, we understand what the answer represents. So we want to find the real solutions here. Okay, so we have a radical. So the first thing we need to do to get rid of the radical is we need to multiply by, we need to square both sides. So we're going to square the left side and we're going to square the right side. So the radical and the 2 go away, leaving us with 3t plus 4, and 2 squared is going to give us 4 because this is saying 2 times 2. So we're going to subtract 4 on both sides, and we have 3t is equal to 0 because these will cancel and then these will cancel. Then we divide by 3. So 0 divided by any number besides 0 is going to give us 0. Okay? And we want to check our work, all right, when we do this, because sometimes there might not be a solution. Okay? So we're going to check our work, so we're going to plug it in there. So we got 3t plus 4, so we're going to plug in 0 and for t. Okay, so 3 times 0 is 0, plus 4 is going to give us 4. So square root of 4 is going to give us 2. And that's what we have here. All right, so that checks out. Okay. All right, now on the right side, we will, in order for us to get rid of the radical, we have to get the radical by itself. So remember that. So a lot of students tried to solve it the way it is, and they ended up not getting it correct. So the first thing we need to do is we need to add 1 to both sides. So again, you want to note, you want to get the radical by itself first, if possible. Okay? So you want to get the radical by itself first, if possible. So that's what we're doing. So we have the cubic root of 1 minus 2x equals 1. Okay? So I have a cubic root. Here we had a square root. So that means then, in order to get rid of the cubic root, we would just multiply by a power of 3. Just how we got rid of the square root by squaring it, we're going to raise this to a power of 3. Raise this to a power of 3. So the root here of 3 is going to cancel with the power of 3, leaving us with 1 minus 2x equals 1. Okay, and then we're going to solve. So 1 minus 1 is 0, minus 2x, 1 minus 1 is 0. Then divide by negative 2. Okay, so that gives us x is equal to 0. So again, when I plug it in, I'm going to get the same answer. So let's backtrack a little bit here. Why does the radical and the square cancel? So I'm asking this question. We have, say this, we say we have x squared. And if I take the radical of it, why does that just equal x?
Because they're opposite operations.
No. I mean, it's true. It's true. They are opposite operations. But why mathematically does that just equal x? So, okay, so the question is again, why, if we have x squared and we take the square root of it, why does it just equal to x? Well, remember the square root of x, okay? The square root of x, another way we can rewrite that is x to the 1/2 power. So if we say, if we have the cubic root of x, that would be x to the 1/3 power. If we have the fourth root of x, that would be, that would be x to the 1/4 power, so on and so forth. Okay? So, anyway, so the square root of x is equal to x to the 1/2 power. So if we rewrite this, again, we have an x squared in the middle, and then that radical now is being rewritten as x as to the 1/2 power. Okay, so again, that radical is being rewritten as 1 to the 1/2 power. Well, remember, a power raised to a power, you multiply. A power raised to a power, you multiply. So 2 times 1/2, well, that's going to be, say, 2 over 1. So that'll be 2 over 2, which is equal to 1. Okay? So basically, these guys are going to cancel, leaving me with just x. Okay? And that's why it works. Okay? Is because, again, the square root of x is x to the 1/2. And if you're going to square it, the 1/2 times the 2 is going to produce a 1. So that's why the square root of x squared is equal to x.